Colby, 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 math.com.
Today we began working with integers, comparing them and ordering them. Integers are all of the whole numbers, which include the counting numbers, 1, 2, 3, 4, 5, 6, 7, etc., and as well as 0, and the opposites, which, for example, for 6, the opposite of 6 would be negative 6. Opposites are equidistant from 0 on a number line, but just in opposite directions. So for problems, I'm going to do problem 13 and 16 with you, I believe. Let me double check. Yeah. But the directions are the same for all of these 13 through 18. So refer to the number line below. We see the origin, 0 on the number line. Everything, the direction of everything with respect to the origin has meaning. The numbers to the right of the 0 are the positive numbers. The numbers to the left of the 0 are the negative numbers. Everything that is, the numbers are increase in ascending order as you go from left to right. So if something is left of anything else, it's less. And then if it's to the right of something, it's more, it's greater. Complete the comparisons by filling in each oval with less than, equal to, or greater than symbols. Compare the locations of each value on the number line in relation to the origin, which is shown near the center of the number line. So in this first comparison for 13, we're comparing A to B. A is negative because it's to the left of the 0, and B is also negative because it's to the left of the 0. But since A is further left than B, A is less than B. And you can conclude that without even knowing what the numbers are, but if it's helpful to assign reasonable numbers, if C, which is the first one I run into as I'm going left, it could be negative 1. Just looking at the scale here, I would say 2, 3, maybe B would be negative 4, and A would be negative 7. And even though 7 is greater than 4, but negative 7 is less than negative 4. If you think of a negative as a debt, would you rather owe somebody $7 or would you rather owe them $4? Negative 7 is less than negative 4. Or if you think about temperature, negative 7 or 7 degrees below 0 is colder than 4 degrees below 0. So A is less than B in this case. Before you do 16 on your own, because I'm going to ask you to pause, recall that these symbols mean absolute value. An absolute value indicates the distance from the origin without respect to the direction. And so if you recall what we talked about regarding absolute value in class, then compare the absolute value of A to D during the pause and then come back and see how you did.
Paused.
The common misconception about absolute value is it means to take the opposite. And so let's just look at absolute value really quickly. The absolute value of negative 2 is equal to positive 2. But the absolute value of positive 2 is also equal to positive 2. Absolute value just means how far is the number from 0. It doesn't mean change it to its opposite. It just means how far is it from 0. So if you look at negative 1 right here, see, it's 1 away from the 0. So the absolute value of negative 1 would be 1. So the absolute value of A will definitely be positive. We just don't know, we don't know what number A is. We've assigned it negative 7 here. That's arbitrary, but let's just note for now that it's positive. D is also positive because it's to the right of the 0. And so how do you compare one positive number with another positive number? Well, the relative distance helps you compare them because A is much farther from 0 than D is. So the absolute value of A will be much larger than D. So absolute value of A is greater than D, even though A itself is negative. I mean, if we use these numbers, the absolute value of negative 7 would be 7. and D looks like it's about, if C is -1, D looks like it's about +1. So you're comparing 7 to 1, and 7 is clearly greater than 1. Okay, I hope that helped with the assignment. I'll see you tomorrow.